So this video I will talk about arithmetic progressions, and I will talk about a very specific type of questions where they ask us to derive the formula, right? Because from my last video, I read the comments, and one of the comments suggests me to make one video for this derive formula punya soalan. So this video I will make one video, but this one is for arithmetic progression. Okay, next video I will make one for geometric progression. Alright. Okay, so this is the formulas that I will derive today. The first formula is the Tn formula. This is the formula to find the nth term. Alright. So Tn means they are asking you to find the nth term. Okay, the nth term. Right. And then the next one is to find the Sn. Sn means to find the sum of first n terms. Okay. The second formula is to find the sum of first n terms, right? And this one is also the same, yeah. But this formula is another formula for Sn. Yeah, there's two formulas. So all these formulas you learn is the formula that you learn in Form 4, the chapter, the progression chapter, right? And today I will show you how I derive these three formulas, alright? Okay, because in the trial paper I did, a lot of questions, there's a few questions that come out that they ask us to derive. Okay, so I will put a star here. Okay, I will put a star here because this one comes out the most. Yeah, in most of my trial papers, you can watch all the trial papers, the video I made on the trial paper. Most, this comes out a lot. Okay, where they ask you to derive this formula. This one maybe come out one time. Yeah, this one I remember come out one time. I forget which state, but I remember got come out one time in one of the state paper. This one also, I think one time only, right? But this one comes out a lot. Okay. Okay. So let's start with the first formula. Okay, the formula is called the Tn formula, and the formula looks like this: a plus n minus 1d. So how do we derive? Okay, first of all, we will let a be the first term. Okay, let a become the first term, and then let d becomes the common difference. Okay, common difference. Okay, so let a be the first term, d be the common difference, and then now we will write t1. Okay, we write t1. T1 means first term. Okay, first term. So the first term will be a because I already let a become the first term, so t1 will be a. Okay, then what about t2? The T2 will be the first term A plus with D, like this. Okay, so to get the second term, you take the first term plus D. Then what about T3? T3 will be A plus D plus D. Do you agree? Because T3 is actually the previous term, which is A plus D one more time. So it becomes A plus D plus D. And you can also write this as A plus 2D. Because d plus d means 2 times, right? Then what about T4? T4. So T4 will be a plus d, a plus 2d, the last term plus d. Okay? It means every time you go down, you plus 1 plus d plus d plus d like this, right? So the a plus 2d plus d, it will become 3d. Okay? Because 2 plus 1 is 3, right? So after you write until here, you can see there is a pattern here. This one a plus 3d, this one a plus 2d, this one a plus nothing here means 1d, right? So a plus 3d, a plus 2d, a plus 1d. What do you think is this? This is a plus 0d. That is why you don't. That's why you never see any d here. It's because it's 0d. 0 times d is 0. That's why you don't see anything here. Alright? But actually it's also plus d but plus 0d. Alright? So I'm just gonna write it here 0d. Alright? And then this one nothing in front is 1d. Alright? So 3d, 2d, 1d, 0d like this. Okay? So now we can generalize. Okay, we can generalize. Now we can derive the formula for Tn. Alright? So T, this is also T. 1, 2, 3, 4, that is the n. Yeah? So n. And then equals a equal a equal a equal a. So this one is also a plus 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 plus. So this one is plus. Okay, what about this one? 0D, 1D, 2D, 3D. So when we generalize, what we have to write here? Okay, when the n is 1, the number here is 0. When the n is 2, the number here is 1. When the n is 3, the number here is 2. When the n is 4, the number here is 3. Do you realize these are all the n values, right? And these n values, okay, is to get this number, alright, you are actually taking the n value minus 1. Because the number here is always 1 less than the n. When the n is 1, this is 0. When the n is 2, this is 1. You see? It's n minus 1. Same with this. When the n is 3, the value here is 2. It means 3 minus 1. And then when the n here is 4, this one is 3. It means the value here is always 1 less than the n. So therefore, when we generalize, the number in front here is always n minus 1. Okay? It's always whatever value here minus 1. Right? And then times with d. Okay? And this is how we derive the Tn formula. And after we derive, we will write this word derived. Okay? So this is how I will derive the Tn formula. Okay? Okay, sometimes in the question they will not use the word derive. Okay? Sometimes they won't use the word derive. They might use this word proof or show. Okay? But it's all the same thing. They are all the same. Yeah? If they say derive, then I will write derived. If they say proof, I will also do the same thing, but last kali I will write proven. If they say proof lah, if they say proof, I will write proven. But if they say show, I will also do the same working, but at the end I will write shown. Okay, but it's all the same thing lah. It's just the same thing, right? So that's all for the Tn formula. Now let's move on to the next formula, the Sn formula. Okay, for the Sn formula, the formula looks like this: n over 2, 2a plus n minus 1d. So how do we derive the formula? First of all, we need to understand what is Sn. Sn stands for sum of first n terms. It means you are taking sum of term. Okay, sum of first n terms, right? So sum means you have to add them up. You have to add them up. So if let's say I want you to find the Sn, what it means is you are finding the T1, alright, the first term, plus with the T2, plus with the T3, plus with the T4, T5, T6, until the last term, right? Until the last term. So the last term, since we don't know our n, I'm just going to call it Tn, alright? So for example, if this one is 7, this one is S7, it means you will take T1 plus T2 plus T3, T4, T5, T6 plus until T7 if this is S7, right? But since now it's Sn, so the last term will be Tn, okay? But if the n is 8 here, then this will be 8 terms lah. If this is 5, then there will be 5 terms here, alright? So, can you tell me, if I put a bracket here, and I put a bracket here, and I put a bracket here, and I put a bracket in all the terms, can you tell me got how many bracket here? How many black color bracket here? How many bracket? It's not 4 bracket, it's not 4 bracket. It's n brackets, right? Because the number of brackets depends on the value of n. If the n is 7, there will be 7 brackets. If the n is 6, there will be 6 brackets, right? If the n is 5, then there will be 5 brackets. Because S5 S5 means T1 plus T2 plus T3 plus T4, plus then there will be 5 terms here, right? So how many brackets here depends on how many terms, right? So it means depends on the n. So there is n number of brackets here, right? Okay, what I want to do next step is to use this formula, this Tn formula, right? So I will write Sn again, but the T1 I will write A, okay? A, okay? And then the T2 I will write A plus D, okay? Okay, I already explained this now, right? Why the Tn formula, I already explained the Tn formula just now, right? So plus with A plus D, alright? And then T3 will be what? A plus 2D, and then it keeps going. A plus 2D, A plus 3D, A plus 4D, A plus 5D, it keeps going. Okay, it keeps going until the last term, until the Tn. But we don't have time to write so many terms. So I'm just going to stop here and use this dot. Okay, because we don't have time to write so many. Okay, I think like this is enough. Alright, and then plus with the last term, which is Tn, And then the Tn will be a plus, okay, we use this formula also lah, a plus n minus 1d. So this is Tn, so this is a plus n minus 1d. Okay? If it's T1, then this will be a. If T2 is a plus 1d, and then Tn will be, the last term is a plus n minus 1d, alright? But let's write one more term before the Tn, okay? So let's write one more term before the Tn. So what is the term before the Tn? It will be Tn minus 1, right? Yeah, it will be Tn minus 1, okay? So the term before will be Tn minus 1, okay? And the formula, what happens when you use this formula? The Tn minus 1 will be a plus n minus 1d, right? But the n is n minus 1. So this thing will become n minus 1 minus 1, which is n minus 2d. Alright? So can you see, I never write a lot of terms. I only write first two terms and the last two terms. Yeah, because I don't want to write a lot. I don't want my working to be very long. Okay? So I only choose to write first two terms and the last two terms. Alright? Of course, if some student they want to write more terms here, can also, it's up to you. Okay, but personally, I think like this is good. First two term and the last two term, right? But there's actually a lot, many terms in between here, but I never choose to write it down. Okay. Okay. After you form this equation, you will call this equation 1. Okay, you will call this equation 1. And now what you will do is you will write your Sn again, but this time you will reverse everything. You will reverse everything. So, for example, if I give you something like this, 1 plus 2 plus 3, right? 1 plus 2 plus 3. If I reverse everything, I terbalikkan 3 plus 2 plus 1. This one and this one, they are the same thing, right? They will give you the same answer. They will both give you 6. Yeah, they are the same, right? So, if I tell you the sum from here to here, it will be the same with the sum from here to here also. If you terbalikkan, it will be the same thing. So let's write down again the Sn, but this time I write it in reverse. I will start with the last term. So I write a plus n minus 1d, alright? Followed by this one, which is a plus n minus 2d. Okay? This one plus this one, and then dot dot dot. The next one is a plus b, alright? And then the next one is a, alright? And I will call this equation 2. Okay? But they are both the same thing. They are both Sn. It's just that it's written in reverse. Alright? And let me ask you this. How many... Okay, let's use bracket. Okay? Let's use bracket. Alright? To make it look nice lah. Huh? So, how many... Okay, let's put them up like this. So, this is the first bracket. The second bracket is here. The third bracket. And then this one is the last bracket. Right? So, how many brackets you have here? It's not 4 bracket, huh? It's not 4 bracket. Huh? There's still a lot of terms in between. So how many brackets here? There's n number of brackets. Do you agree? Because the number of brackets, okay, these brackets come from the atas punya bracket. So this bracket also is like this. Okay, we will also group them up like this. Okay, like this, right? So can you see the number of brackets here will be the same as the number of brackets here. And the number of brackets here come from here. That is why the number of brackets will be n. There will be n number of brackets here. So same with here, there will be n number of brackets also. This one also got n number of brackets. And now what I want to do here is I will take equation 1 and equation 2, I will plus together. I will take equation 1 plus equation 2. Okay? You can take equation 2 plus 1 also, it's the same thing. Right? So what happens when I take equation 1 plus equation 2? I will get Sn plus Sn, which is 2Sn. Okay? It means I will form a new equation now, and the equation is 2Sn. Right? And when we will plus like this. We will plus this with this, this with this, this with this one with this one. Alright? So first one is we will take a plus n minus 1d. What happens when you take the sum of this, when you plus a plus a? So a plus a, you get 2a. And then plus n minus 1d, right? A can only plus with a, right? So when you take the sum of these two terms, you will get 2a plus n minus 1d. And then plus, now we will take the sum of this, right? We will take the sum, we will plus, right? So what is a plus d plus a plus n minus 2d? So we are taking this plus this. So what happens here? A plus a, you will get 2a. And then what is d? plus n minus 2d. Okay, I will write here d plus n minus 2d. Correct? D plus n minus 2d is right. So how can we plus? Okay, we will expand. We can expand, right? So what happens when we expand this? When we expand, we will get nd minus 2d, right? And then what is d minus 2d? You will get nd, okay? And then 1d minus 2d. What is 1 minus 2? Negative 1. So you will just get negative 1d like this. So this is your answer, nd minus d. Let me ask you, what happens when you expand this? What happens when you expand this? What you get here? nd minus d, right? Can you see it's the same thing here? It means what you get here is exactly the same as here, which is plus n minus 1d, because nd minus d, you can pull out the d, you can factorize the d like this, and then become n minus 1. Okay? Which is exactly the same as here, right? That's why here and here is the same thing. Okay? And let's put the bracket nicely. Okay? Okay. So now I will erase this and continue. Dot 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 dot. Okay, now we will plus these two terms together. Right? So what happens when you take this one plus this one? So you take a plus a, which is 2a, and then plus what is n minus 2d plus d. Okay, we will do the working here. So n minus 2d plus d. We can expand, you will get nd minus 2d plus d. Okay, and then what is negative 2d plus d? Negative 2 plus 1 is negative 1. So you get negative d here, and then there is nd in front. So it's nd minus d. But did you realize nd minus d is the same as n minus 1d here? Because when you expand, you will get nd minus d, right? N times d is nd, negative 1 times d is negative d. It means the answer here will be the same as what you write here, which is n minus 1d. Okay? Because nd minus d, when you factorize the d, you will get n minus 1d. Right? And let's put the bracket nicely also. And then plus with the last one. Okay? The last one, you will take this one plus this one. Right? So what happens when you take this plus this? Okay, a plus a, 2a, and then plus with n minus 1d here. Right? Because this one only have a only. So a and a plus is 2a, and then n minus 1d, there's no d here, so we just write it down like this. Okay? And then don't forget to put the bracket. Okay? And then this one can erase. Okay, now I already formed a new equation that is called 2Sn, right? But I'm trying to prove the formula for Sn, not the 2Sn, right? So what I will do now? Okay, did you realize all these things, they are the same, right? 2a plus n minus 1d, 2a plus n minus 1d, this one also the same, so they all look the same, right? But now my question to you is, how many of these you have here? The 2a plus n minus 1d, how many times it appears? How many times this thing come out, right? How many times? It will be n number of times, right? Because the number of bracket depends on the n value, okay? Because the Sn, when you find Sn means there will be n terms, okay? So how many terms you have here? It will be n. So the 2a plus n minus 1d, okay, it keeps on repeating, and it repeats how many times? N times. So I will just write n times with this, okay? And the other side here is still 2Sn, okay? And now you can find the formula for Sn. You can just pin down the 2, and when you pin down, it becomes n divided 2, big bracket, 2a plus n minus 1d, and then you can write derive. Okay? So this is how you prove the Sn formula. Okay? So that's all. Right? Okay, let's move on to our last formula. This formula is also the Sn formula, but it's a different formula. Okay, it's a different formula, and the formula is like this: n over 2 a plus l. Alright. Okay, L stands for last term. Okay, L stands for last term. Okay. Okay, how can we derive this formula? We will use this formula. We will use this formula to derive this formula. Okay. So what we have to do now is we have to write down this formula first. Okay, which is after we write down this formula, we will write down Sn equals n over 2. Okay? Do you realize this formula is n over 2 also? Right? But this one is a plus l. Right? It means this one is 1a. 1a plus l. Right? But the formula here is 2a. So what we can do is, how can we make the 2a becomes a? Okay, we can write it like this, a plus a. Right? Because a plus a is 2a, right? Okay, a plus a. And then plus n minus 1d. Okay? It means the 2a, I just separate it, becomes a plus a. Okay? And why I change the 2a become a plus a is because Sn can equals to n over 2, and look at this. A plus n minus 1d. Isn't this the last term? Right? Because a plus n minus 1d is the formula for Tn. Right? It's the formula for Tn. And the Tn you already jadikan dia last term. You already make Tn the last term. So it means this one, a plus n minus 1d, is actually the Tn formula. Right? A plus n minus 1d is Tn. So it means Tn, and since Tn is the last term, or in the Sn progression, it means you can just use L here to represent the last term, the Tn, okay, the last term. And then we will just write comma, L stands for the last term. Okay? And then derive. This is the working. Okay? Alright, so I should separate this. Yeah. So first formula number 1, formula number 2, formula number 3. Okay? So yeah, that's all. This is how you derive all the formulas in arithmetic progression. Okay.